Today I want to play around with autoencoders. I have this idea, but I have to say that I'm not a machine learning expert, so it's quite possible it's not going to make any sense what I'm doing, but let's give it a try. So we'll be working in Python. Actually, what I want to do first is make something called, I want to generate some data, and we'll use that to train the autoencoder. So let's try pre-prompting ChatGPT. You are a programming assistant. Please provide concise answers when you change something in the code. Try to make the change as minimal as possible. Ask for clarification if necessary. I have no idea if this last thing will make any sense because it doesn't really have any idea of doubt or anything like that, but I've seen other people do that, so I'm going to try it. So the first thing I want to do is generate let's call it synthetic data. Author, interesting. This is not my name. Still not my name. Let's, so what do I want? So I want the synthetic data is an array of circles with some random noise added to their positions. So something like that. Okay. We need to generate synthetic data for training an autoencoder. The data should be images of a square array of circles. Let's say it's 9 by 9, like a Sudoku. Circles should be evenly spaced, and there should be a small random offset to their positions. Let's try something like that. I just realized I forgot to tell it that we're working in Python, but thankfully it chose to do that itself. So I will let it finish because it's quite slow today, and then I'll get back to you. Okay, so it's generated something here. Let's get that code over in the editor. Let me zoom out slightly. And what's it saying here? Okay, whatever. Okay, so we use NumPy, use pillow, generate some image with a width and height, grid size, circle radius. So the grid size is the thing that should be 9 by 9, looks like. And it's defining something called grid width, which is a bit weird, but whatever. Circle radius, offset range. So we make an image, we do some kind of draw. I'm not sure what this does, so let's ask about that. What does image draw image do? Anyway, so we define this, which is like how much space there is for each circle. If I am to just look at the right hand side, left hand side is a weird name, but whatever. Okay, so we loop in a square grid. There is some offset, which is a random integer, sure. The center is the is given by the I and j, half the width and height. That's good, I like it, plus the offset. And then we draw an ellipse. So this draw thing is making a draw object that can draw on the image. And it had some kind of error. Let's try again. And it's making them black, which is fine. So it's a white. Let's change this. Let's make it like kind of gray, like that. And this one we can make kind of blue, or some, I'm not sure what this is, some kind of blue. I don't want those quotes, kind of weird that I had those actually. So it draws an ellipse and then returns the image, that's fine. 300 by 300, 9 by 9, circle radius is 10 pixels, offset range is 5 pixels. It's a bit small. The circle radius, I actually don't want that to be, what is it using this grid with? Let's try this. Okay, so now we have kind of a decent script. Let's try to run it and see. Bunch of errors, that's fine. Can I do image.save or something? So I don't get those like that. Okay, that kind of works. Now obviously there's nothing there, so let's make it black and this one make it white. Let's try the original settings. Okay, interesting. So what is the circle radius? I probably made it too big. $33. Maybe divided by 2. Okay. So I guess that's all right. Let's make it even smaller. Okay, this I kind of like. Let's go with that. Okay, let's try to change the colors again because I don't want to look at that. So we'll make that one blue. Bluish. And this one will just be kind of a dark gray. Let's make it, no, it's not good. So this one has to be darker. And this one has to be more blue. This is very important that the colors are just right. Going to my... Okay, let's go with that. So I suppose there's also a possibility of drawing a square. Let's do center X plus circle radius. Center Y plus circle radius. Maybe something like that. Okay, so how can I draw squares instead? Or it's called rectangle. What's fill? That worked. Okay, so that's squares instead. Let's just check. Okay. That means fill. Let's define a variable for the color. And we'll put it here. We'll say fill is this thing. Great. So the reason I want to be able to draw squares as well is that this is what I want to try on the autoencoder. What happens if you replace one or more circles with a square? Okay, so now let's make a folder called training data. And then we're gonna say if name equals main. And then we'll say pass arguments. Test. Which generates a test image. And 2, which doesn't generates training images. And then we'll say from, we'll see if Copilot can figure it out. And then if, and we have to pass them as well, so we have to say args. And if args.test, then I want to run this code. Otherwise, if train, then we'll raise not implemented error. And else, can I like print usage somehow? Okay, great. So let's try that. I really hate that it uses those guys. Okay. Okay, so let's say generate training images, and we'll take a folder as argument, but the default is this one. And then we'll say, also it needs a number. So let's say number of images. Actually, let's just make both of them non-default. So for all of these images, let's do that more or less. Great. And down here we will say 1,000 images. It's a bit much. Let's start with 100. And I didn't call it that. I called it training data. And then we will do that. And up here, actually, let's say if I plus 1, yeah, exactly. And I don't want to do that. I want to do more like something like this. So let's try it. Train. Okay, quite fast. Also in the end, let's print a new line. Let's try that again. Okay. Looks quite nice. Let's look in the training data. Now there's a bunch of training data. Great. Let's look at just one of them. Synthetic 42. Beautiful. So, and I just realized we can try a couple of things. We can try to both make a square and we can make a different color. Let's call it fill. When we try to use the autoencoder. Okay, but that's it. So I've generated a training set using this code. The data is stored in a folder called training data, and the files are named synthetic x.png, where x is a number between 0 and 99. Please help me write a script to train an autoencoder using PyTorch on this training set. All right, so finally it has finished everything. It took a couple of tries. This is where we left off. Please help me write a script to train an autoencoder on this training set using PyTorch. It set some steps. And then it actually kind of failed here, as you can see. But this gave me an idea. Maybe it would be good to prompt ChatGPT or give it like a system prompt that tells it that whenever it wants to implement something, then it should provide a list of steps to take and then not do anything until I say step 1. And then it does step 1 and step 2, because that will limit the size of what it generates and could also allow me to change what it does. So I actually quite like that. So let's say in the future, before implementing anything, write a list of steps to take to do the implementation. Do not implement anything until I say step n, at which time you should implement the nth step. I'm going to copy this because I want to, let's see, no, it should be here, ChatGPT script. So let's make a prompts text file. Okay, that didn't. No, it did work. It's just there's no line wrapping. Okay. I want to also work on this ChatGPT bot that we made the other day a little bit more. Let's do like this and like this. Okay. So where were we? We were here. Okay, the first thing I want to do is we're gonna make a training file at some point. So let me make that now. And what I want to try is just to see if all of these imports work. Okay, so no problem with that, which is great. So I want to put things into some kind of nice folder structure. So let's make one that we call synthetic dataset. And then we will take this guy. And I think I got the right imports, but let's see. Data loader is not used actually. And we also need OS. And I don't want that comment. So there's evidently some dataset class in Torch. I'm not sure what this is. In image.open. Or let's say, what does the convert method do in PIL? Let's just try that. So what is this class doing? So it has a root directory. So build a training set, a transform. I don't know what that is, but we'll leave it for now. And it has a file list where it looks in the root directory and finds all the PNG files. Also good. You can ask for the length and you can get item n, whereupon it will make the file name, open it and convert it. And if there is a transform, it will transform the image and then return it. We may have to do some kind of normalization here. Let me actually check that. Let's just make a quick test here. Let's say image is image open synthetic dot png and then print image and exit. Let's try that. And I want to run Python 3 generate images. And it's a PNG file. And now what happens when I convert it? Image mode L. Don't know what that means, but let's see. Convert method is used to convert an image. L is grayscale, interesting. that means we cannot try the thing where we change the color, but I'm fine. No, actually I'm not fine with that. Okay, what I want to know is, how is this used? Images to device runs. Like, surely that cannot work, that is just returning a PNG image. Like, shouldn't it have to make it into an array? Can I do that? Yeah, they cannot. Okay, so I can do this. So I may want to do that. Let's print the shape first. Okay, so maybe I have to turn it into an array at some point. For now, we leave it. Then let's go ahead and make the autoencoder class. And we will need some imports. We will need import torch. And I think that's it, apparently. Let me replace these guys with a new line. Now, okay. So first we have a convolutional layer, and then a rectified linear unit, another convolutional layer, and this is the encoder. What's confusing me is that it seems the dimension is going up, and normally it should be going down. So what is the meaning of the input arguments to this guy? But then there's a forward method, which is you encode and then you decode. And then it's inheriting from neural network module. So I'm assuming that that is defining like a training function or like derivatives or something like that. Okay, so this is the number of input channels. I don't want it to be grayscale, so I'm gonna do this. So if we go back here and we say undo and we run this, then it has 3 channels. So that's good. It's not, it doesn't have an alpha channel, was what I was checking. Yeah, so why is it going? Okay, so it's going from 3 channels to 16 channels, 16 channels to 32. But all the while it's also making it smaller, I guess, because of the convolution thing. Okay, let's assume it's correct for now. So that's the autoencoder. Now we need a new file that we will call... Actually, let's just put this in train. And we will also do that one. Okay. Let's format it. So we need to import torch. And we need to say from synthetic dataset, import synthetic dataset. From autoencoder, import autoencoder. And import torch.nn. There's an easier way to do this. So evidently this is not used, this is not used, dataset is not used. And undefined name. It's because I accidentally deleted this line. Okay, let's go over it. So there's a train function, which takes a model, a data loader, a criterion, and I guess it's like a loss function based on this line down here, this one. There's an optimizer. There is a device, which will be the GPU, hopefully. There is the number of epochs. And then there's this call to train. What does the call to model.train do? Okay, so for some number of epochs, we run over a set of images. So we'll do like batches. We send them to the device. We zero the gradient, calculate the output. We calculate the loss function. We do automatic differentiation in backwards mode. We do one step of the optimizer, and then we accumulate the loss for whatever reason. And then we look at the total loss for that epoch, print something nice. Training data, batch size 16, that's fine. Learning rate also fine. All of this can of course be optimized. I want to say if torch.cuda is available, else print using CPU. I just want to know which one I'm doing. It should be the GPU. I should have CUDA. Let's finish this. So there's something called transforms, which I guess is like data augmentation. There's a resize and a to-tensor. Okay. So it just, you can have different images of different sizes, I guess. And then there's here where it's creating a tensor. That's what I talked about, turning it into a NumPy array, but now we turn it into a torch tensor. Then we make a data loader from the data set with the batch size, and it shuffles it. We create an autoencoder, send it to the device. The criterion is mean squared error loss. The optimizer is the Atom optimizer. And we train the autoencoder. It looks like it should work, but it's a lot of code and it hasn't been tested. And to be fair, like, I don't know how this dataset class works. And I don't know if this is the way you do it. I mean, it certainly looks correct from what I know about autoencoders. Except that I was confused about this with the channels, but enough talking, let's try. Train.py. No module named Torch Vision. Let me install that. Okay, so finally it seems to be working. Let's try to get this thing running again. Using the GPU, great. And now there is some kind of problem. Expected input. I got one channel instead. So let's have a look at the data set where, of course, we forgot to remove this one. Let's try it again. Using GPU. Another runtime error. Quite interesting. Because I thought that we had this. Let's raise an exception here, because I thought we had this resize thing enabled. No, same thing. Let's print transform just to check. Yeah, so we all the time have this resize. Okay, let's ask ChatGPT. By the way, so the call to model.train sets the model to training mode. So that's great. I am getting the following error when I try to run the training script. Okay, so it told me it's something to do with padding and output padding, and it's telling me to remove the output padding. So I guess we can try that. Still, there is some problem now. So now it's something that's too small. I'm a little bit surprised. Let's see. So torch size. I want to check that the shape is all the time the same. Okay, so we can do that. And then we can assert that this is equal to 16 by 3 by 300 and 300. Right? Yeah. And so that's the starting thing. And then I want to assert something here, and I want to assert something here. So the output should definitely be the same shape. When it's encoded, it should be something else. Let's just run this to check. Okay, so it just fails. So let me, and it doesn't tell us what's wrong. So let's do this. $64, $38, $38. 64, 38, 38. Okay, and it fails on the output, which is what we kind of expected. Even after I did this thing, let's check that the rest is the same. 3 2 1 3 2 1 3 2 1 3 2 1 3 2 1 3 2 1. And here it says 4 2 1 4 2 1. Interesting. That didn't work either. Let's try to add this back in. So it fails right away. If only I knew, like, what is this intermediate sizes. So stride 2, so is it like dividing it by 2? No, not really, because there is how does it become 38? Which is weird. Let's try to ask it. How can I decide the size of the latent space? In the meantime, let's try to tell it that the size we want is not 300 by 300, but like 256, 256. Now, of course, this will just fail. Okay, so now it worked. 300 was not a good number for some reason. Okay, so we managed to train an autoencoder. Now we want to, first of all, let's go up here and let's say generate synthetic image, and we'll add, like, let's call it square probability, which is by default equal to 0. We'll add a random number. Yeah, sure, like that. And if we okay, there we go. So if we, with some probability, we draw a square instead. So let's do parser add argument, and I don't want to, what do I want to call it? Let's call it square. Generate images with some circles replaced by squares. All right. And then we'll say else if args.square, then we will create 10 images and sure they can be in there, and training images, then we want square probability to be 0.2 is a fine number. Square probability by default is 0, and then we need to add it in here. And now I want to do that. Okay. The latency side, I don't really care about this anymore because we just got it to work, and I just want to make something that works kind of quickly. So let's say make the training data square, and then we'll see here. Okay, now we can use the square one, and inside the square there's a bunch of stuff. So let's look at number 4. It has some squares, which is great. So now I want, so first of all, it's training it, but is it saving it? It's not saving it. Please add some code to save the trained model. Okay, here we go. To save the trained autoencoder model, you can use torch.save, add the following lines of code after a training loop. So there's some saving, and we can also save the model, load the model, sorry. So let's write a couple of functions. Just save model, and it should take a path as well. And maybe this is a bit redundant, but here we go. Then we'll say load model, and it should just take a path. Interesting that it already sends it to the device. Didn't really expect that. And then model, we want to load that one and set it to eval and return the model. Okay. Let's put the path first in both, just for fun. And actually I want to say that if os.path exists path, then we do all of this. Otherwise, the model is just an autoencoder to device. This doesn't exist, so we're going to port OS. Now it's happy. So now we should be able to say that this thing we don't need. So we can say load model, and the path is can be autoencoder pth, and here we're gonna say path on that device. Once it's trained, then we will say save the model. There we go. So here I also want, like before we train it, so in here it's automatically set to training mode, so that's all right. I don't know, let's see if it works. So that's not what I wanted. This is what I wanted. Zoom in again. So let's try to train it. Use the GPU. Some loss. It kind of converges to the same loss as before. Now there should be a file, autoencoder path, exactly. Then we train it again. Should start from a lower loss, and indeed it does. And ends up on a lower loss. Let's try it one more time. Starts from an even lower loss. It's not exactly the same as before because there's this randomization in the training. Okay. So final thing is, now we want to load the model and apply it to a test image and output the result to a file. Okay, here we go. So it already forgot about this thing that I said that it should give me the list of steps, and then only when I tell it, it should give me the next one. But maybe if you put that command in the system prompt, it's less of an issue. So let's make a script now that, just because I'm running out of ideas, I'm going to call it test. This is the path. We need to import torch. We need to say from autoencoder, import autoencoder. And there we are. Tensor to image, tensor clone, detach. Okay, so we clone the data in the tensor, we detach it from the GPU or device, I suppose. We turn it into NumPy. It's transposed for whatever reason. I guess, whatever. Then we change the type and we turn it into an image. Again, we take the this path, we find the device we can use, we make an autoencoder on that device. We load the state, the trained model, we turn it into evaluation mode. The image we want to use is called training data square, and training data square, it's just called synthetic 0.png, and we can call output image. So again, we have this resize where the size should actually be 256 to 56, as we find out that worked. It should not be grayscale because we changed that. So transform on squeeze, I'm just going to assume that's correct. Then we call anyway, so then we convert it, and then we, let's say we save it. Okay, let's try that. Test.py takes a long time. Cannot convert. Use. Okay, so use tensor.cpu to copy the tensor to host memory first. Okay. Okay, so it did something, and it was called output image, and this is kind of cool. So let's look at them side by side. Training, square, synthetic 0, and this one. Now obviously it's not the same size. Let's convert this one, square, synthetic 0, resize to 256, 256, and we'll call it input image.png. Can I do that? Then we'll say input image. So now they're the same size, a bit easier to compare. So look at this. I mean, it has turned these kind of round. So as I kind of expected, it's learned that there are round things, and it can find out that here's a round thing. And then that is what is storing in the latent space. And probably if we made the latent space even smaller, then it would only, like, they are still like a little bit square, right? You can kind of see that this one comes from a square and this one comes from a circle. But if we made the latent space even smaller, then the only information it could store is the location of the circles. And then it would have to make it fully circular. So I think that's very interesting. Also the fact that the output is not perfect. I guess we just trained it for more epochs or make more training data, it would be better, but still interesting. Okay, that's it for this video, and I'll see you in the next one.